everyone. My name is Anton Bukov. I'm co-founder of 1inch, and I'm gonna tell you today about some interesting algorithms in DeFi, which I find the most interesting ones, and I'll tell you why. So we can see that DeFi computations are very limited. And this is happening for many years, and we all wait till blockchain adoption, and we believe that blockchain computations will scale eventually with sharding or anything else. But I'm in this industry for like 7 years or something, developing protocols, and I don't see that computational capacity is actually increasing. So yeah, we should work with what we already have, and I believe we still can have highly scalable or infinite scalable protocols in current state of DeFi and blockchains. So yeah, that's what I'm going to show you, some algorithms in their projects, and I will describe how exactly they work. And yeah, this is not only for developers, hackers, builders. This is also for understanding how different are those projects from each other and how they are different from other projects which do not use, for example, such cool scalable algorithms. So first of all, here you can see there is a classification. You can see it's like distributing value. It's about value redistribution among multiple participants. So it can happen in the same value or in the another value, different asset. It could happen instant or it could happen gradually over time, each second, each block, something like that. And it could depend on direction. It could be dispensing value or collecting value from big number of users. So here I have examples of some projects which already have those algorithms, and I classified them. So yeah, let's start from the beginning. You can see that same asset, instant dispensing, you can find AMM's logos. So what does it mean? Whenever someone uses AMM pool for swap fee is being accounted in being redistributed among infinite amount of liquidity providers. It does not matter if it's like 10 providers or 1,000 or million or even billion providers. Computational cost for this is the same because this algorithm have constant complexity. So next one in this table is same asset gradual dispensing. Let's start with this slide. So how money markets usually work? So those who borrowed liquidity, their debt is increasing every second or every block. It's being accounted like that. And they, like, you can say they're paying some annual yield. For lenders, it looks the opposite. Lenders get value, also accounted every second or every block depending on the implementation. But it's happening gradually. And the thing how it works inside, you could think that it's like collecting values and dispensing values here, but actually implementation of money market is different. They're using same algorithm in both sides. They're dispensing debt and dispensing collateral. So that's why they all, money markets are listed there in gradual. And projects like Maker, which are, I mean, they have similar algorithms and apply them similarly. So yeah, one more corner here is same asset instant collection. So there is a joke about rug pull. It happens instantly and collecting money from every participant. But also protocols, here is Opium logo, but there could be much more many projects which are actually like insurance protocols or options or other derivatives protocols. So whenever settlements happens, they're collecting funds from pool of participants. That's what I meant. And you can see that the different asset, is not really popular among different projects, but I'm not sure that I have all DeFi projects here. For sure, I can't be aware of every project, but it's for the most popular. So if you have projects which are not here, but like should be here or here, let me know. I will add them for the next time I will have similar presentation. So yeah, different asset gradual dispensing is something what we called farming. And it was initially used in Synthetics protocol, and now it's being used among many protocols. Moreover, this primitive of dispensing different assets gradually could be used inside of many other protocols. So let me check what is the next slide. Yeah, and I forgot about this interesting use case. Right here you can see same asset gradual collection. I found only one project which is doing that. It's called Papaya, and it's infinite scaling money streams. How does it work? So you could set up streams which are actually constant streams, like how many assets are being transferred in 1 second, in 1 minute, in a week. It's been constant. So you can open a limited amount of outgoing streams, but for sure you can have infinite amount of incoming streams. So this protocol found a way to have settlement without enumeration of incoming streams. So it does not matter if you have 1,000 incoming streams or 1 million or even 1 billion of streams. You can get money from all those streams within one short transaction. How does it work? This protocol stores total speeds of incoming and outgoing streams for every account. Whenever someone's open new stream or close stream or change stream, these numbers are being recalculated for involved participants, and then you can count your next balance based on your previous balance, how much time passed since this moment, and your total speed. So sounds basic, but that's what allows you to have infinite scaling money streams actually. If we will see Netflix or YouTube or Twitter or OnlyFans or Patreon or anything else on blockchain, they should use accounting like that. So they will be able to charge millions or billions of streams with constant complexity. Gas cost will be the same for any amount of subscriptions. So yeah, one more point here is that whenever you see something is happening instantly inside blockchain, it's also, there is a room for manipulation here, and by default, those protocols, they are vulnerable to front-running and sandwich attacks. For example, whenever someone sees that huge swap is coming to AMM and huge commission will be earned by liquidity providers, there is a possibility to inject your liquidity right before this swap to get significant share of those fees and then remove your liquidity. That's what's happening. JIT liquidity, just-in-time liquidity. So on this slide you could see, for example, your liquidity provider with 3 millions of 3 different assets, DAI, USDT, and USDC, and there are 3 different pools. It's like Uniswap version 2 or maybe Curve or anything similar. So whenever you see huge swap coming to one of those pools, you could inject your liquidity. You could inject 2 millions out of your 3 millions. So that's how you can simulate 6 millions of liquidity, but you only have 3. If you would use more assets and involve much more pools, your coefficient will be much higher. Here is like virtually doubling your liquidity amount. But for sure, you will spend some money on fees for making those transactions. So it's not passive participation in AMM. It's more active participation, but it have own benefits. And on some networks where those transactions are like super cheap, it's more than feasible. And yeah, those projects which do this instantly, they have possibility to protect from this for sure. This can be done in 2 steps. For example, projects in same asset instant collection such as insurance protocol, derivatives protocol. They lock user funds, and whenever settlement is happening, they charge users. So it's not possible to run away before settlement. Yeah, but some things like AMMs are still vulnerable. And yeah, but for example, for Uniswap, you can do Uniswap v4 hook. For those who provide liquidity, you can make it as a two-step action. First step to commit your deposit, and then you have to wait a few minutes, and then you can deposit, something like that. I mean, you could have some algorithmic protection from this if you consider this is something you want to solve. And that's it. Any questions? Easy, yeah? That's why I'm talking about it. Because it's easy to understand that some protocols already utilize algorithms with constant complexity. And that's actually a huge benefit for them because they are already ready for mass adoption, because they're ready for millions or billions of users, because each of these users will make transactions only when they need to do like real actions, when you need to borrow or lend, or you need provide liquidity, or you need swap, and you don't need any extra transactions for accounting. You don't need to collect funds, for example, from millions of subscribers, because it will be nightmare. You will I don't know if any blockchain can allow this. Like if Netflix gonna have subscriptions on blockchain, I don't believe that they're gonna do hundreds of millions transactions every month. We don't have such blockchains yet, and I don't believe we will have such blockchains in 10 years. And yeah, we have questions.
Yeah, so specifically to Uniswap hooks, you said that that could be one of the problems solving potential. I think they've advertised it as one of the bounties where you hook to, and then I've got an idea that you said before the liquidity provider is actually committing, you can put something in between, but I'm not exactly sure which logic would stay between there.
Yeah, guys asked me to repeat questions before answering them. So yeah, in short, you asked about this slide where I told about instant actions, instant distributions of values. And you asked about Uniswap v4 hook, that you heard that there is a bounty for something similar to this. Yeah, I think it's possible to make protection from just-in-time liquidity providing. And you can make it, the only way you can protect from this is making it two-step, but yeah, it's not that simple. If you would make it simple to step, like commit that you will deposit and then deposit, people will commit and then wait till something is happening and then they will deposit. But yeah, you could came up to something not very, it will be not very difficult, but I think you can came up to something what would work fine for this. Yes?
You talked about algorithms in terms of computational complexity.
Yeah.
What about memory space complexity? Do you think it will change the picture that it will be not actually scalable in the ways that memory is not free, even if we are doing charging? What is your position about the memory space?
Okay, I'll repeat your question because I was asked to do this. So, yeah, I talked about computational complexity, but for sure there are other complexities for other parameters of those algorithms, as memory, consuming notation, and other things. Yeah, I think this is also important, but I never met protocols which have which store much more data than actions that are happening. I mean, like for one storage slot, for few storage slots, for like some actions, for some users, you do not like explode on data which you need to store in smart contracts, because it's actually the most expensive thing in blockchains. It's like it costs insanely more comparing to computations. Like for like numbers, adding numbers is like 2 or 3 gas, while storing new slot is 20,000 of gas. Updating existing slot is 5,000. So numbers are really wild for storage. Yeah, one more thing regarding complexities is that whenever you consider those complexities for your algorithms, anything which is like linear to number of participants or something like that is very dangerous. Because when you write smart contracts, you should always think about computational complexities, because your computation is actually limited by the block size. If you need to perform like loop in your code over participants or something like that, it will stuck whenever you have few thousand of users, because this loop will consume more than 30 million of gas in Ethereum mainnet. And yeah, I mean, the size of block is mostly comparable for the most of blockchains. So I don't believe we have any blockchains which have like billions of gas or something. But yeah, this is something what auditors will tell you if they will see you have a loop over something which can grow dramatically, which is not limited in terms of its size. Yeah, auditors will usually let you know that this would not work, and you can split this by having this loop in multiple transactions. But I would suggest you to reconsider algorithms you use to don't have those loops at all. Yeah, that's probably one of the reasons why this farming smart contract became so popular in 2020, because yeah, any amount of participants can be participating in this farming, and they can all join, get out at any point of time, and values will be distributed among participants in a fair way. And all those methods to join, get out, claim, they will all cost the same cost. Doesn't matter how many participants are participating. Okay, you asked about asynchronous and non-atomic blockchains, which are probably sharded or something like that. And you asked how it will be affected, those ideas of scaling and computational complexity. I think it will be the same. I mean, making things asynchronous or non-atomic will not make it easier for you. It will be it will actually cost more, because it will be like a separate transactions, not like an actions inside one transaction. So yeah, hopefully you have to consider your algorithms, how it works on a different level. So yeah, this presentation is also about how people should build new protocols, think how they should consider new algorithms which are being used inside their protocols. And yeah, one more point is for people who are trying to understand how different projects correlate with each other, which one is better for this, which one is more suitable for this, because yeah, we can see in DeFi the huge variety of different protocols, but they all have different implementations, and they are being optimized for a little bit different things. Yes? Could you repeat?
Sort of instead of imperative language, declarative language.
Yeah.
Can that address any of the scaling issues?
Potentially yes, because when we are talking about declarative programming languages, I always start thinking about SQL, because that's one of the most popular ones. And the idea behind declarative languages, I think, so it was to make some optimizations which is hard to achieve with imperative language. For example, with SQL, query, you use indexes to boost complexity of your query, but you are not aware of those indexes actually. You do not use them implicitly, explicitly, you use them implicitly, and potentially some things could be integrated. I mean, we could see some declarative programming language for smart contracts which incorporates some ideas of indexing to achieve something. I think it's probably possible, yeah, something like that. Yeah, the difference between imperative and declarative thing is in imperative you tell what exactly is happening in your code. In declarative things you like, it's like intents, you ask for what you want to get, what you want to achieve, and actual things which are happening, they're happening under the hood, probably under the compiler or something. It depends on the implementation. Thank you for the question. Thank you, guys.